So, I will start from the point where Dr. Hamdi has left, that urbanization and urban areas have exacerbated the process of climate change. They have contributed to climate change. He has shown all the slides showing all the justification and the science behind how urban areas are contributing to climate change. Now, going ahead, once we know that urban areas are actually contributing to it, there are many factors that contribute to climate change. Some are the form of urban areas, the others are the processes that happens in an urban area. So, let us check what we left in the last lecture. So, it was like the city geometry, the heat from human activities like industrial, domestic heating, heat retaining properties of the buildings, water and vegetation. So, we as a planner have a role to play here. So, how should our buildings should be, how should our city planning should be, so that we can at least work towards reducing the our contribution to climate change. How can we adapt to climate responsible manner? So, this is what we will be looking in our further slides. So, the contents will be urbanization, climate change and heat islands. So, I will be focusing on urban heat islands more. What are the different types of urban heat islands? Variability in the urban forms, because now we have come to the scale when we are talking about urban areas, and urban areas are not same. So, some areas are different, have higher density, some are lower density, some have less trees, some have more trees, some have some areas are closer to water bodies, some are far from the water bodies. So, it is a feedback that is important for us to understand how our cities are being planned and what is the feedback which is it giving to the atmosphere and to climate, to urban warming and to urban heating. So, we will discuss here is about the concepts, methods and tools for investigations. So, we all know that urbanization is happening and it is a process of large number of people coming permanently concentrated in a smaller area or smaller place. So, that is what is urban. Since many years we are seeing this phenomena where the whole purpose of having an urban area was that there are common benefits. So, people from different industries, different sectors, they all come together because there is a mutual benefit they are having. So, in a small place there are many people coming together, working together and for a common good, common place for mutual benefits. So, it is just because it has economic benefits, it has social benefits, it has cultural benefits, there could be many reasons of coming together. So, but by coming together we are actually increasing this density, and this is what is actually we are looking into how this density should be managed. So, we can see that the less developed regions are having are been projected to have more population, they are growing with a greater rate than the less developed areas. And the transformation that we are seeing from these cities are in terms of growing population, that is urban population growth that is happening, the surface area which has been increasing, that is called urban footprint, like how much area is being occupied by buildings, by pavements, by on urban land, that is a matter of concern and that is what we can look into, and the increasing infrastructure, pollution, mental stress, again this is what is now we have in mind as urban. So, looking at the linkages that we have to urban to climate change in a very simple terms, that we are actually increasing our footprint, our urban form is increasing. So, when people want to get together, they are coming together, there are CBDs being formed, then that means there are more built area in a small place. So, more population, more density of population as well as built density that is what we are looking into. then greenhouse gas emissions, the buildings, transport, etc. is contributing to the carbon dioxide emissions, which is again a contribution that urban area is having more than the rural areas. Then air quality, again we all know this increases, urban areas have more issues with the air quality as it increases further to the heat. Then heat related illness. Why? Because we have more population, more vulnerable population coming together. So, the heat related index illness is more, disease has been more, because all gets exacerbated in urban areas. So, we become more vulnerable in urban areas, and this is again the climate change impacts which is happening. Otherwise, the warm climate change is happening and again increasing or adding to the urban areas. So, simply because this has been taken in previous lectures, we will just quickly move forward. So, there is climate change which is actually otherwise also increasing the temperatures. Then there is urbanization, which is actually with the help of the built environment. We will just focus on built environment currently, but because it has a particular type of urban form, it is actually modifying the outdoor environment also, because when buildings come together, it also changes or modify its outside air conditions, humidity and other aspects of the environment, which again increases or changes the indoor environment. We use more AC, we consume energy, and then again that feedback is there towards the climate or climate change and adding to the climate change. So, this is what is happening. So, it is a feedback loop which we are into it, because there is climate change, we are mitigating or using more energy and then adding to the climate change again. So, this is, but urban heat island is again an impact of climate change, which is being created by urban areas, urbanization and also through climate change. So, we will focus on urban heat island, and why are we focusing on urban heat island here is because we are concerned with the human comfort or human or heat stress that is happening because of urban heat island. Because urban heat island has further many more impacts, but today we will focus on, because we are building for ourselves, we are building shelters for ourselves. So, how these buildings should be created, how sensitive it should be done, so that we can reduce the impact of urban heat island, and what are the different heat island which we should look into. So, there are urban heat islands which are surface heat islands and atmospheric urban heat islands. So, you can see this is the layer which we are considering as the atmospheric urban heat island. This is at the surface which we call it surface heat island, and canopy level urban heat island is this, where we are considering the building heights, the heights of the trees, and which is all considered under canopy urban heat island. And under this canopy under heat island again is related with the local level, micro scale level, and surface heat island again we have seen in Dr. Hamdi's presentation the surface air temperature that we are looking into at 2 meters, that is at human height. What is the air surface air temperature that we are concerned with, because all this is actually leading to the heat stress or the change in thermal environment which is caused because of surface heat island and canopy layer urban heat island. So, if we look in this picture, we will understand that there are different urban heat islands, and every type of urban heat island has to be investigated in a different manner. So, there are different observation methods that we look for, and we will be looking into these observation methods in our future tutorials, what kind of observations has been done and which kind of observation are needed for what kind of urban heat island that we are investigating. So, when we talk about urban areas, it is majorly this canopy layer urban heat island, which we are looking into or we are investigating, because this is what is changed because of our planning and design of our buildings, our areas, our zonation, etc. And surface heat island is again what kind of land surface it has, or what kind of cover it has, which contributes to surface urban heat islands. Again, why we are looking into? Because urbanization leads to rapid haphazard growth. It leads to certain kind of urban forms. It will lead into, because all areas are not same, this is our hypothesis that we are working on, that it is all heterogeneous in nature. So, all areas are not in similar type. Every particular type of urban form will have a particular thermal profile. It will have certain areas which are more vulnerable than the other areas, and what we are focusing on, what are those areas which are more heat stress, so that we can take adaptation measure to mitigate this heat stress. So, as I said before, we will be focusing on surface urban heat island and canopy layer, because this is what is actually modulating our thermal profile at urban built level, and this is the research domain that we are looking into right now. So, before starting, you can see this picture from Mumbai, and you can see, sorry, आप फिर से कर देंगे? Yeah, this is a typical picture of Mumbai, which tells a lot of story about Mumbai, like the build form which is coming up, the new contemporary build form. This is the slum areas or low income group housing which is spreading all around, plus there is a certain kind of physical form which is already there in Mumbai. So, this is the physical features which are there. So, every area, we cannot say Bhopal is a particular type of thermal profile, Mumbai or Delhi, but there are within Mumbai also there are many changes, there are different forms, and these forms are heterogeneous in nature. When we call heterogeneous in nature, it means that within a small distance there are changes in urban form. So, it is very difficult to understand what kind of build form has what kind of feedback to heat island impact, or what kind of thermal environment or thermal profile it will give us. But to start investigating, we try to categorize these urban forms and understand what is the impact of a particular form to thermal stress or thermal profile of that area. So, if we look into the urban forms, these urban forms have a particular urban atmosphere. There is particular wind speed, wind direction. There are urban biosphere, that is trees, built environment, surface type, etc. There are hydrology which is existing. There are other lithosphere, maybe rocky, maybe soily, different types of soil, and a building system that exists or that we built here. So, in all, there is an urban ecosystem that is formed because of all these components in the urban area. And these urban components are not static, but there are wind flowing, there is sun path, there are other processes, because this is just there are transportation, there is vehicle movement, there are also air conditioning. So, all have a very complex compound effect in an area. So, what we did was that we try to understand what are different forms and what are different temperatures, and whether there is a variation between the forms or not. To do this, what we did was that we went to Mumbai, we selected those areas which are somehow homogeneous within a distance. So, 1 kilometer grid we have taken, and within 1 kilometer grid we have selected those areas which have a particular homogeneous form. What we did was that we use sensors, that is thermal sensing sensors like air temperature, humidity, etc. And then we wanted to understand what is the exposure level to at these different urban forms. So, with this hypothesis that different forms had different kind of thermal profile, first we started with understanding how Mumbai is and what are the different forms existing in Mumbai, and we were surprised to see that that you can see here that these are the built up areas, the orange ones, and these built up areas have very high slum population in all these wards, right. So, all the wards of Mumbai had almost 40% to more than 40% of slum population. And then what we selected, this was one level of study that we did at the city level, in which we have looked into the surface temperature, land surface temperature, and the other was an area we selected where again we found different types of forms. Okay. So, as you can see, this is a water body. There was a high rise apartments here. These black were these slum areas or low income housing or slum areas which were having a spread in this area, and then there were again these kind of housing which were slum rehabilitation authorities housing. So, they are called SRAs in Mumbai, and so we have taken this area because we could get all types of urban form within this 5 kilometer by 5 kilometer area. So, we started investigation in these areas. So, first level of investigation was the surface land surface temperatures, where we have first categorized into the formal housing areas and slum areas, because we wanted to differentiate and see whether these two urban forms have a different type of thermal profile, and we divided into grids, and we found that a land surface temperature is different in these two areas. You can this is the temperature grids. Each grid is showing the LST which is presented in this area. And when we did Moran's eye analysis, we found, or scatter plots, we found that these areas, that is slum areas with different resolutions, because that is again a problem of what size of grid we should use. So, to understand the sensitivity, we did this Moran's eye, and then we found out that formal areas have and informal areas are like formal areas are concentrated in one area and informal areas are concentrated in one area, and there is LST, lagged LST. So, these areas have similar kind of land surface temperature. So, we could say that they are forming a particular form, urban form, which is significant. And again we did another bivariate LISA analysis to understand whether there is a cluster formation between the form and temperature, and to validate this with a Moran's eye of 0.4 is showed very high condition in these areas where there are slums. And if you look into the Moran's eye value, if it is from 0 to 1, and if it is near 1, that means it is significant. And to validate this phenomena, we used our thermal cameras, and we found that the temperature in these areas are much higher than the rooftop of formal areas, and thus this validated our hypothesis that two forms are very different. And this same research has been published in Environment and Urbanization. So, you can go through the whole paper and how the analysis was done. So, we try to do this partial association between form and LST in two different forms in an Mumbai area. Again, again when we use this area, now we had different forms and we wanted to investigate between different forms. We use this sensor module, and using this simple temperature sensors and relative humidity sensors we developed in our lab itself. And what we did was to have 2 to 3 types of sensors put in each type of urban form. So, you can see A, B, C, D. So, A was the high rise apartments, Hiranandani area. This was B was the slum areas, then C was the SRAs, that is Slum Rehabilitation Authority housing, and D was again the slum, this is slum areas, and this was again another type of housing, that is the government housing which was there in this area. So, we have installed these sensors and took a long term sensing for an 8 days to understand how much variability was there in temperature and humidity in these areas. We are taking temperature and humidity because these are the simple parameters which can give us heat stress. So, this is how we have put the sensors in a pole, and we had to protect it from the radiation, and we have to install it at a height which is 1.5 or 2 meters from the ground, so that it can sense what a particular human thermal comfort is being assessed at. So, we have put up in these areas identified, and you can see from this picture, this is SRAs or slum rehabilitation housing, which is and you can see a very interesting picture where after the evening, like in other areas, like the sun comes up whole day, it heats up the area, heats up the land, and after 6 o'clock the temperature used to go down drastically. This is the phenomena everywhere, that after 6 the temperature goes down because there is no sun, no radiation, and the areas start cooling. Even if in our areas we see that okay, the cooling has started, but these were the areas, that is slum, the heat was trapped in these buildings, and this is the time where they could not stay indoors. They had to go out, they had to sit out, because that is what they felt, because inside they said अंदर इतना suffocating है, there is no air flow, and there was lot of air, hot air which is trapped in these housings. So, this was the phenomena that we saw in these slum rehabilitation authority areas. So, apart from the air temperature as well as relative humidity sensors, there were another types of sensors that we have used here, and these were globe temperature. So, globe temperature is for that we have used this instrument which was highly accurate, with having a resolution of 0.3 degrees centigrades, and because we wanted a high degree resolution or accuracy instrument, sensing instrument, because if you ask you what is the temperature difference between this and outside, how can, or within one area, so wherever you stay and in wherever you work, the temperature difference will be maximum how much in 2 areas? We will see 2 to 3 degrees in tree or shaded area maximum, but if it is all open areas, the temperature difference will not be more than 1 degree. So, it is very small difference that we can see from in one area to another area. So, we need that high resolution instruments to sense that variability. Okay. So, again it is very important that what kind of instrument we are using for sensing. So, we will do this practical tomorrow or day after tomorrow. So, see how much difference, we will go to Manet Institute and we will see how much difference is there in our academic campus area, within the campus area, in academic block, in residential area, near the water body, in the forest area. So, how much actual difference we are getting. And again if we take the temperature, here in our institute, and if we go to take the temperature in say New Market area, TT Nagar, where we have lot of emissions, we have vehicles, we will see there we will find a very large difference between this and that area, because there is again the emission, the heat being trapped, and the other particulate matter which is adding to the heat. So, this we have used because we wanted to see the daytime temperatures also, because air temperature, relative humidity and wind speed, all these things are very important factors when we understand or we try to understand the thermal profile. But if we try to understand the radiation which we are getting in an area, we have to use globe temperature, because this is the property of a surface, how much radiation is being absorbed by a black body. So, that is the globe temperature where we use, and this is required when we see how much heat is there on the surface, then we, and how much variability is there between two areas, then we have to use globe temperature, that is Tg. So, using first type of sensors, because it is very difficult to take that high resolution sensor or the instrument to different places and to stand there and do the recording. It is more easier for us to install those wall mounted sensors. So, we have installed the wall mounted sensors in the different areas. You can see the 3 types of buildings where we have installed these sensors, and we have left. So, we have to inform the police stations, we have to inform the society people, we have to inform the local people that we are putting up these sensors, because they should not misunderstood as some other thing, and there should not be any vandalism or misuse of these sensors that we have put. So, we have to put it in a way that it is open enough, so that there is an air flow. So, it has to be protected enough, so that the radiation does not tamper the readings of air temperature and humidity. So, taking all care, we have installed this for a longer period, and then what we saw was, you can see this in high rise, the temperature used to go very high, but it used to drop to below 30 degrees. You can see during this time, evening time, when there was, and then it started rising in 2 o'clock, right. And but there was some time in the evening when then it started dropping. But in this is mid-rise SRA housing, where the temperature did not go up because it was all shaded, but it did not come down for a longer period or during the day. This is the whole day, and again it started increasing. So, this they did not have, the window of comfort was very less in these areas. And if we look into the low rise informal housing, it did not go up, but it also came down, and then again it started rising. So, there was because there was some kind of airflow which was happening, and it did not have the temperature also did not rises to beyond a limit. But these were the areas, or these the SRAs, the mid rise compact housing, where the temperature could not go down and there was heat stress that was found. So, otherwise Mumbai is does not have very high heat, but still there was lot of heat stress. Why heat stress? Because relative humidity was very high. So, there are 2 parameters we are looking into, temperature and humidity. So, it is not only the temperature, but also the wind flow, which acts a very important factor when we talk about heat stress. It is recorded, right? Okay. So, this was a good evidence for us to say like 3 different forms have a different types of heat stress, thermal profile, and we need to now design buildings in a way taking care of what kind of build. So, we can see the heights are different, the distance between the buildings are different, the spread is different. So, there are many things which takes into play when we talk about the thermal profile. But this was one study that we did. But to further understand the physiological PET or physiological equivalent temperature. Again we looked into the different forms that we have taken, and this was again an index which tells us whether what is the comfort level for human at a particular in a particular area, and here we have used this TMRT, that is being calculated using globe temperature, and we can see the variability in these areas. So, earlier it was just air and relative humidity, then again we wanted to look into the globe temperature and see how much variability was there in all the 5 urban forms. And again the point here is, even if the temperature is high, it matters more how much exposure we are having to that heat. So, to uncomfortable conditions. So, one, it is the intensity, and the second is the exposure of heat stress environment at a particular location. So, that again we saw in SRAs, the exposure level was much higher in these areas. So, this is simple again index that we calculated or formulated. This is, you will not find anywhere in any city studies, but you can find in one of the papers have shown this graph. So, I will just quickly say, it is very important to see the temperature rise and how it is coming down. So, in various other places we see that temperature rises and it comes down around 6 o'clock in the evening, the temperature come down. But if there are many areas where the change of temperature is later, very late, it happens late and it does not goes down to a limit to give comfort. So, then again the time plays a very important time factor, and this we are talking about the diurnal changes that happens in an area. So, again there is another aspect that we are looking into, how a place is getting heated and how much it is cooling down. So, this is the cooling index that we have calculated. So, looking into all these factors again, then we thought, that was Mumbai study, and we wanted to look into other aspects also. So, we have now understood that urban form has a different characteristics, different thermal profile. Then we came down to Bhopal and then we tried to see how a particular what can we do as a planner. So, what we did was we calculated the thermal load components in an area. This is a study that we have initiated in Bhopal. We are still working on it, but this is the framework that we have started with. This is already a published paper in 2023, and it looks into, like, this is the common simple framework of the research that we are doing. We calculate the thermal load components in an area and thermal cooling factors in an area. So, we are calculating the thermal load assessment and cooling potential assessment of a place, of an area, and then we created an urban climate sensitivity map. We identified these sensitive zones, and then what should be the recommendation for future planning of our area. So, now we are having a draft master plan coming off. There is a draft master plan, the master plan coming off Bhopal, and if we consider all these factors, probably we will be able to do a justice to the research which is going on, and what as a guideline, as a bylaws we should be looking into to make it a climate sensitive master plan. So, this is a proposal, or this is the idea that we have for Bhopal. Like, what we should be doing is to calculate the thermal load. So, we using these parameters, we try to understand what is the thermal load, and then using build index, NDVI, NDVI. So, there are certain factors which, as I said, that increases the thermal load. There are factors which are cooling factors, which reduces the thermal load or cooling. So, when we have a combination or balance of the two, we will be able to have a sensitive design. So, why we are saying so? Because any area will not have only buildings. it will, so for example, a building will increase the thermal load and vegetation will reduce the thermal load. So, it will have a cooling effect. So, what is that right percentage? What is that percentage that we should look into when we are planning the cities? So, that is the research, that is the question that we have in mind. So, some areas will have a higher FSI. So, if it is in higher FSI, what is that percentage of vegetation we should have? What kind of material we should use? So, there are different variables that we are looking into, which will help us to design a climate sensitive urban form, which will be suitable for that area. And when I am saying area, it is because this area which is closer to lake may have a very different kind of form, and this area which is far from lake may have a different form. Why? Because of water body, there could be some kind of urban cooling of the air which can happen, and then the wind direction. So, wind direction also plays an important role. So, all areas are not same. We cannot have a one common fit size for the whole area. So, urban form can have a variability, and we can some areas will be closer to water, some areas will be closer to national park, but some areas are rocky in strata, some areas are may need a this old area, Bhopal area has already been an heritage core of, so we cannot change much. So, what can we do in this core area? We cannot dismantle those buildings because it has a heritage value. But what about those fringe areas where the new development is happening? So, what is that form that we should have? What is the FSI we should have? What are the building bylaws? What are the vegetation or greening bylaws we should have, so that we can sensitively design these areas? So, that is what we should.
In case of Bhopal, there are 3 urban forests which are located.
Yes, urban patches, the green patches we can call.
Yes. So, even locational aspects can
yes.
also be evaluated.
Yeah,
and in the planning, we can suggest the places which can be designed as a green spaces. Because forests तो हर जगह रहते हैं, but requirement कहाँ पर है urban areas में.
Exactly.
So, in geography we have little bit deal with that thing. So, that was in my mind कि हम vegetation के locations को भी decide
कर सकते हैं,
और वो government फिर plan करके
वो कैसे करेंगे? तो this is why this framework was right, कि हमको ये तो देखना है कि what is adding to the thermal load, but where it is. So, question of where or spatial relation is also important. So, I have not shown this in my slides, but my PhD, my doctorate was on where, the geographical weighted regression I have employed. So, where, what kind of form should be there is being taken care. So, that is a published paper, the geographic, so you can search on my profile, you will find it is in Area Development and Policy Journal, International Journal. So, there I have dealt with the geography of the urban form. So, its distance from the, because in Mumbai I have again considered that area which has Powai Lake, which is closer to the areas. So, if a particular form is closer to Powai Lake, it will have a different kind of form, it should be having a different kind of form. If it is having a green patch nearby, it will have, because spatially also the impact will start decreasing. If it is a green area, nearby it will be a good thermal environment, but as you go far, that impact will start decreasing. So, that all has to be considered. So, there is smaller research which are needed for, say, water bodies, there are small area research which is needed to understand this decay effect because of a green patch on urban forms or thermal profile. So, there are many things which needs to be looked into, but this work has been done for Mumbai, we are trying to do for Bhopal now. So, yes. So, this way we could actually calculate the thermal load in the city of Bhopal and cooling potential of the city of Bhopal. So, cooling potential was based on the closeness to the water body, closeness to Sanjay Gandhi, sorry, Sanjay not the National Park, Vad Vihar. Sanjay Gandhi National Park was Mumbai. So, this way we came out with the urban climate sensitivity analysis map. So, urban sensitivity map tells us which grid has what kind of thermal load and cooling potential. So, we could categorize area into say high thermal load and low cooling potential. So, areas which have high thermal load and low cooling potential, there we recommend that no further residential area, industry areas or highly thermal load inducing form should not come. If the areas have low thermal load and high cooling potential, there we have possibility of having more buildings or inducing build areas. So, this was a basic analysis that we did, and we categorized into zones and then came out with recommendations for our development control regulations for this for Bhopal area. So, these were the recommendation where we could see which are the areas which are probably suitable for future expansion in Bhopal. So, what are the potential development, which are the areas which should preserve, and what are the looking into the wind direction and the form that we can envisage in a particular area. So, this was it, and now we are again going to another level of categorizing into local climate zones. Like local climate zones are again a particular type of classification which is done, which includes built, water body, green, percentage, and we can categorize whole Bhopal into different climate zones. And why we are calling local climate zone? Because each area has a different type of fractions of built, fractions of green, fractions of water. So, this I will be taking up in tomorrow's lecture. What are the climate zones and how should we go about understanding the climate zones and its contribution to heat island. So, one of my PhD scholars has worked into it, and we will be showing this work on its relationship between climate zones and thermal profile on land surface temperatures. So, we have started work on it again, doing sensing and categorizing the area. Next we will be doing simulation analysis, and this is what was some kind of urban development policy variables that we can which can be contributed, which should be considered in our master planning process, which is not considered. One is FSI. So, structural form is now also considered in our master plans, but sky view factor or the openness between the buildings, as we have seen in SRAs, there were less of opening or open to sky areas. So, that is the geometric feature that we have to look. So, till now we are only talking about FSI, number of floors, build coverage, but we need to understand the sky view factor or openness to sky. Why? Because we need air movement, we need air flow, because then only we can reduce the heat stress. Baki sab jagah whatever can happen, only as human what we are concerned is heat stress, because that is the worrisome thing for us in future also. So, to reduce that heat stress we need openness, and that too also we do not need much of openness, because then the radiative heat will increase, but we need a balance of openness so that the air should flow and reduce the thermal or take the heated air away from that place. So, this is the sky view factor that we need to be considered. Again the place, the geography, the geographical location, distance to ecosystem providers, whether it is water body or green. So, all these things needs to be added in the policy to consider a climate sensitive development. Yeah.
We have to sky view factor, but is there any thumb rule for deciding what can be the sky view factor we should consider?
There are now many research on this, and they have come out with a particular sky view factor which is suitable for an area. So, we in my studies also we could find that sky view factor ranges from 0 to 1. So, 1 means completely open and 0 means not open at all, no sky at all. And generally the spaces in local climate zone, we will discuss this. The sky view factor is again a very important parameter in categorizing and classifying the local climate zones. So, generally we have 0.2, 0.4, but then we have to, this should be, and there could not be a one common rule, because the meteorology or the weather condition of that place also plays an important. If it is very high heat, then we do not recommend high sky view factor, because if you look into Rajasthan, where there the buildings are densely packed, because they have a low sky view, because they need shading. It all depends upon the other variables also, like what is the height of the buildings. So, if the height of the buildings are more, they will have a shading, then the sky view factor open is okay. But if it is very closer, so we have to look at the geometry of a place. So, we cannot say this is the appropriate or this is the one which should be followed. So, it will be variable from place to place, and if then we have to consider whether we are looking into surface heat island or whether we are looking into canopy urban heat island, because when we are talking about canopy urban heat island, which is related with the heat stress, then we need airflow, then we need openness. If we are talking about surface heat island, then the more surface is exposed, it will be heated. So, then we need a closer, less sky view factor, and it will be variable from one place to another as per the climate. Okay. Any other questions? Okay. Thank you. I think so. He will continue with the another lecture.